Hi, can you find the radius of this small circle? This small circle is trapped inside a quarter circle with radius 3, and we've got a chord inside that quarter circle of length 2 with a perpendicular line to that chord going down to the base of the quarter circle and also tangent to the smaller circle, which is also tangent to the arc of the quarter circle. Can you find the radius of that smaller circle? I'm going to show you my solution very shortly. Before I do that, here are the key points labelled in case you want to show me your solution down in the comments below. And as I was saying, I'm going to show you my solution in a few seconds. So pause the video now if you want to have a go yourself. I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I did was draw a radius in the smaller circle and extend that side over to the right hand side. Now the reason that I did that will become apparent shortly, but what I do know is that tangents to circles make an angle of 90 degrees to the radius. So I've got these right angles. From there, if I call this angle theta, this is 180 minus theta, and then because angles in a quadrilateral add up to 360, this must be theta, and likewise this must be 180 minus theta. Now what that means is those two quadrilaterals down there are going to be similar shapes because they've got all the same angles, and what we'll see in a second is that they are both kites. So what we've got in the smaller quadrilateral is that these two blue lines must be equal because tangents to a circle that meet at a point must be equal in length. Now, likewise, that means because we've got a kite on the left-hand smaller quadrilateral, the similar shape, that larger quadrilateral on the right-hand side, must also be a kite, which means that this length is also the same. That's also a blue length. So those blue lengths must all be equal. Okay. Now, we're going to remove those sides and those angles for now because the important point is that those blue sides are equal in length. If we then introduce another radius, we have got a length of 3, and we've got an isosceles triangle here. But what I can do now, which is good, is I can work out an angle here using the inverse cosine rule, or cosine rule rearranged. I want to work out this angle A at the top right. Now to do that, I'm going to substitute into this cosine rule, or inverse cosine rule formula, and I'm going to get this, which gives me an answer for A of 70.5287 ... Now for the rest of this video, the answers to, or the values I'm going to work out, I am going to round them when I put them on the diagram, but I am going to make sure I use the exact values so I don't get any rounding errors. Okay, so let's put that on the diagram. Now as I said, this is an isosceles triangle, so this angle must also be about 70.5 degrees, which means we can work out this angle, which is 19.5 degrees, and we can also work out this angle, which is 109.5 approximately degrees, because we've got a large quadrilateral with two right angles in it, 70.5 approximately, so we can work out, by taking those three away from 360, the final angle in that large quadrilateral. Okay, now from there I am going to work out this angle X, or sorry, not angle, this side X at the bottom right of the quarter circle. Now I'm going to do that using the sine rule, as you can see. I've got the 19.5, which is opposite, and I've got 109.5 approximately, and the opposite side to that, which is 3. So I can use the sine rule for this. Now if I substitute into that, I get this, and again I'm using the exact values. Rearranging, we get this, and that gives a value for X as 1.0606 ... And again, we are going to approximate them or round them and put those onto the diagram. Now from there, we've got that all of those blue lengths are 1.06, and we're very close to being finished at this point. What I now want to do is split this small left-hand kite here, or left-hand side kite, into two, because then I'm going to get two right-angled triangles with a side that I know is about 1.06. Now all I need to do is work out an angle. Well, if I call this, or these angles, alpha, they have to be the same because we are splitting that kite into two, so they will be equal, and I can work that out by doing 180 minus that 109.471 ... and splitting that in half, giving an answer of 35.264. Now I can then use trigonometry, right angle trigonometry with one of those triangles, right angle triangles, and I've got the opposite and the adjacent that is involved in my calculation, so that is going to be the tangent. So tan of alpha is equal to the opposite over the adjacent, which is r, the radius, over 1.606 ... Rearranging that, we get this, which gives a value when we substitute in for alpha of 0.75 as the radius. How cool is that? That's such a nice answer to seemingly, some random values in there, nothing which seemed to be quite nice, and yet in the end we get this quite nice number, 3/4. If you were able to solve this problem yourself and you had a different solution, please share it down in the comments. Otherwise, thank you for watching. Please drop a like on the video, consider subscribing to the channel. Have a great week, everybody, and I will see you next week, Monday, 5 PM, for another problem solving video. Till then, bye-bye.